today's lesson, we are going to learn about the nature of the roots. Now, this is just an introductory lesson, so we are going to learn what this means, where does it come from, and what is important to memorize. Now, here we have a quadratic equation, as you can see. Now, we can usually solve a quadratic equation by doing factorization, or using the quadratic formula, or doing completing of the square. Now, for nature of the roots, we are going to make use of the quadratic formula and show you where it comes from. So if we want to calculate the x answers, we can write down our formula, and usually if these were numbers, we can do substitution of the b's and the a and the c as well as the a in the denominator. Then we get two answers for x. Now, these answers for x are called the roots of the equation. But we do not want to know what these answers are when we are talking about the nature of the roots. We just want to classify these answers. So we just want to tell you what type of numbers this will be without actually calculating them. Okay, got it? Now, how do we do that? Well, we make use of this b squared minus 4ac that is inside this square root. Okay, so that is called the discriminant. And the discriminant symbol is this triangle, which is the Greek letter for delta. So by calculating delta and getting an answer for it, we can actually say whether the roots will be real or non-real numbers, whether they will be rational or irrational, or whether they will actually have equal answers, so that means the two x's will be the same, or unequal. Okay, so that's what we're going to learn today, and let's go and see how we can apply it. Now, like I said earlier, this is just an introductory lesson, and now I'm going to show you what is very important to memorize for this section. Now, when we work out delta, and we're actually not going to calculate it today, we will do it in the next lesson, but let's say you work out delta and it's equal to a negative number. Then we will say that delta is less than 0, and we know that the x answers will actually be non-real roots. Got it? Okay. When delta is equal to 0, we know that the x answers will be equal roots. In other words, that means that there will only be one answer because both x answers will exactly be the same number. And we will also know that they will be real numbers. Okay, so when delta is equal to 0, we have equal roots, and there will also be real roots. When delta is bigger than 0 or greater than 0, we know that the x answers will be unequal roots. So we will get two different answers for x, and they will also be real roots. Okay. Then we also have to check whether delta is a perfect square or not. Because if delta is a perfect square, we know that the roots will also be rational. And when delta is not a perfect square, we know that the roots are irrational. Now, do you remember what is a perfect square? That means that when we get the square root of a number, we get an answer without it leaving us with decimals. Okay, so then we can also spot from all of this information one last important thing. That when we have delta is equal to 0, we can see that we have real roots. And when delta is greater than 0, we can also see that we say that the roots are real. In other words, when delta is greater or equal to 0, we know that we are getting real roots. Now, that's just one last thing that you can remember. Now, let's look at a quick example. Now, let's say we calculate delta with the discriminant and we get an answer of 9. So delta is equal to 9. Remember, we didn't calculate x. We are going to talk about the nature of those x answers. So when we calculate delta and we get an answer of 9, we can run through this that we memorize. So if delta is less than 0, which it's not, because 9 is not less than 0, so we don't have to write down this description. when delta is equal to 0, well, 9 is not equal to 0, so we don't have to write down this description. When delta is greater than 0, well, yes, because 9 is greater than 0, we will have to write down that the 2x answers will be unequal roots. So we write down unequal. We also know that they will be real roots. So we write down that the answers that x will also be real numbers. And then we also have to check whether delta is a perfect square or not. Now 9 is a perfect square, so we also have to say that the roots will be rational. And there is our answer. There we go. So now we can say something about the x answers without actually calculating them.